In this video, I'm going to show you how to factor quadratic trinomials that are not perfect square trinomials. So the easiest one that we're going to start off with is of the form x squared plus bx plus c. Now this is the easiest one because there is no coefficient in front of the x squared. So to factor a trinomial that looks like this, we want to find two numbers that multiply to c here, which is the constant of the trinomial, and then those two numbers have to also add to the value of b, which is a coefficient of the middle term. So for example, we want to factor x squared plus 9x plus 20, and the two numbers that multiply to 20 and add to 9 are going to be 4 and 5. So what we're going to do with those two numbers is we're going to place them in a binomial where it's x plus 4 and x plus 5. So we know that x times x will give us x squared, and then the 5x and the 4x add to the 9x, and then 4 times 5 multiply to give us 20. Here's another one. So two numbers that multiply to negative 20 and adds to 1. So there is no coefficient here, but the coefficient is actually 1. So those two numbers are positive 5 and negative 4. So we can put x plus 5 and x minus 4. So again, let's do a little mental check. X times x is x squared. And then we have negative 4x plus 5x, which gives us 1x. And then 5 times negative 4 is negative 20. All right, well, what happens when there is a number or a coefficient in front of the x squared? Now, I'm going to show you two ways to factor this. The first is by guessing and checking, which I actually kind of like. Once you get pretty fast at them and you do lots of examples and lots of practice, you'll actually get very good at this. And then the second method is factor by grouping, which always works, but it takes a little bit longer sometimes. Okay, so let me show you how to factor by guessing first. So you know that when you factor, when we're done, because this is a trinomial, it's quadratic, we're going to end up with two binomials where the outer two terms are multiplied and added to the inner two terms, just like how we did in the first two examples here. Now we know that the first term in each binomial is a product that will give us 2x squared. So I'm actually going to rewrite it like this. So what multiplies to 2x squared, we only know two numbers that do that, and that's going to be 2x and 1x. So I'm going to place them underneath the 2x squared. Okay, now we know that the back terms, or the second terms of the binomial, are multiples or factors of negative 12. So I know that 4 times 3 is 12. So let's pick one of them to be negative. So let's say I put 4 times negative 3. Now I know that when I place them in here, let's say I put 2x and 1x, and then I put positive 4 and negative 3. If I multiply these together, I'm going to get negative 6x plus 4x. Now that's not going to give me 5, so that means that doesn't work. But notice that 2x is multiplied by negative 3, so these two numbers get multiplied, and then 1x gets multiplied by the 4. So what I'm trying to do is to find these numbers here, in the second column here, that multiply, and then when I add the results of these multiplications or these products, I'm going to get 5x. So let me change this. So let's change them around and see if that works. So I'm going to put negative 3 here, and now positive 4. So what I have is 2x times 4. It's going to give me 8x. X times negative 3, that gives me negative 3x. When I add these two together, I get 5x. Great, that's what the middle term that I want. So what happens is I can actually place 2x minus 3 and 1x plus 4, this is actually positive 4, into these brackets. So I'm going to have 2x minus 3 and x plus 4. So let's do a check. So 2x times x is 2x squared. 2x times 4 is my 8x, which is what we got here. Negative 3 times x is negative 3x, which is this. And then when I add them together, I'm going to get 5x. And then negative 3 times positive 4 gives me the constant of negative 12. Okay, let's try another one. So this time we have 3x squared as our first term. Now, when the first term is a prime number like 3, it actually makes it pretty easy because we only have one choice. So we have 3x and 1x. When we start with numbers and they're like 6 or 12 and there's multiple factors, then it gets a little bit harder and trickier. So the other one we have is negative 20. So let's try negative 5 and positive 4. So when I multiply, I notice I get 12x. I multiply this way, I get negative 5x. Now when I add them together, oh, I'm very close. I get 7x, but I actually want negative 7x. So that probably means that my numbers are correct, but the sign of them should be reversed. So what I'm going to do is I'm going to erase the negative from the 5, and I'm going to place it on the 4. So now what I have is 3x times negative 4, which is negative 12x. X times 5 is positive 5x. So now when I add these together, I get negative 7x, which is what the middle term is. So remember, we're going to create our two binomials just based on this. Now I can't just leave this and go, hey, here are my factors. I actually need to write them side by side. So I get 3x plus 5, and then 1x, or just x, minus 4. So let's do that check. 3x times x is 3x squared. 3x times negative 4 gives me the negative 12x, just like I have here. 5 times x gives me positive 5x, so when I join them together, I do get negative 7x, which is the middle term. And then 5 times negative 4 is negative 20. Great. So let me show you how to do the same two questions, but I'm going to show you how to factor by grouping. All right, so I have the same questions. So how we factor by grouping is we take the first term, which is 2, we should say the coefficient, multiply by the constant, which is negative 12, and I get negative 24. Now, very similar to how we factored when it was just x squared plus bx plus c and there was no a value. We want to find two numbers that multiply to negative 24 and adds to 5. So those two numbers here are positive 8 and negative 3. So 8 times negative 3 is negative 24. When I add these two numbers together, I get positive 5. All right, so what I do is instead of writing 5x, I'm now going to split it up into these two numbers that add up to 5. So that'll be plus 8x minus 3x, and then my constant at the very end is minus 12. Okay, so then what I do is I'm going to factor from the first two terms. So 2x squared plus 8x, I can factor out a 2x. And then I have x plus 4. And then I'm going to do the same thing with the last two terms. So I can factor out a negative 3, which leaves me with x plus 4. So what I can see that these two big terms, I could call them, what these two have in common is that they both have an x plus 4. So I'm going to factor out the x plus 4. And then what I have left is 2x and then minus 3. And you'll see that this is actually the same as what I calculated and factored above. So remember, and I'll do a formal check here, which I didn't do anywhere else, but always check after you factor. That way you'll know actually if you're getting this correct. So x times x, 2x squared, minus 3x, plus 8x, and then 4 times negative 3 is negative 12. So that gives me 2x squared plus 5x and minus 12. All right, let's do the second one. So 3 times negative 20 is negative 60. Two numbers that multiply to negative 60 and adds to negative 7 are negative 12 and positive 5. So again, we're going to replace the negative 7 with these two numbers. So negative 12x plus 5x minus 20. Okay, so we're going to factor the first two terms separately from the last two terms. So we get 3x, and then we can also, that gives us x minus 4. So remember, factoring is dividing. So plus 5, and this factors out, I get x minus 4. Now, one very important to stress, which I forgot, is that we need to make sure that these two factors here are the same. So if they are different, then you know you've done something wrong. So then go back and check to see if you've picked the right two terms here that go in the middle. All right, so both of them have an x minus 4. I factor that out, and I have 3x plus 5 left. So what I'm doing when I say factor it out is that both of these terms are common to both of these bigger terms. So I'm factoring out the x minus 4, leaving me with 3x plus 5. All right, to finish off, just a reminder that regardless of the type of expression, always remember to factor the common factor first and then continue factor. So for example, here in this first question, I can see that 8x squared and 200 both have a common factor of 8. So I'm going to factor that out first before I do anything else. So I get x squared minus 25. So from here, I can see that this is actually now a difference of squares. So I can now factor that to be x minus 5 and x plus 5. Now, when we factor, we need to keep bringing the other numbers down. So the 8 should keep following all through the way. In the second question, I can factor out a negative 5. So then I have x squared minus x and minus 20. So bring down the negative 5 again. Now I factor this trinomial. I'll find two numbers that multiply to negative 20 and adds to negative 1. And that's going to be negative 5 and x plus 4. Okay, the last one, I can factor out a 2. So then I get 4x squared minus 5x minus 21. Okay, so doing my guess and check method, I'm actually going to just place the brackets already. So the 4 is a little bit confusing because it can go 1 times 4 or 2 times 2. So I'm actually going to do the 21 first because 21 is such a big number. It's most likely not going to be 1 times 21. So I'm going to choose negative 3 and plus 7. So I know that these two terms, when I multiply them and add it to these two terms multiplied, I need to get negative 5. So if I put 2x and 2x into here, I see that I get 14x minus 6. And 14 minus 6 is actually going to give me 8. So that doesn't work. So let me erase this. Erase that. So no matter how I replace 2x and 2x, it's not going to work. So let's try x and 4x. So I know that x times 4x is 4x squared. So x times 7, I get positive 7x. And then here I get negative 12x, which gives me negative 5. That's looking promising. And then negative 3 times 7, as my last terms, gives me negative 21. So that's great. So this is now completely factored.